Hello, everyone. Yes, we're going to be presenting what's new in OpenBridge Designer and in OpenBridge Modeler. Now, I'm Alex Maverick. I'm the manager of the Bridge and Tunnel Group. Yes, a Tunnel Group, because officially since September 2nd, now we're offering Open Tunnel Designer. So as if you maybe missed Francois' presentation in the morning, this Open Tunnel, it's the first and only software just to combine the physical model of tunneling with the analytics or geotechnical analytics done in this case with us in Plaxis. So, and all within a DGN environment. So it's a specially dedicated application. You don't need any extra programming or extra scripting that it used to be done when we are developing tunnels. So I invite you to download it. It's, as I said, commercially available since September 2nd. So saying that, let's go back to the topic. OpenBridge Designer. This is the new release, upcoming new release, 2022, release 1. And for OpenBridge Designer and OpenBridge Modeler, this is the platform in which we develop the software. It's based on MicroStation, the latest MicroStation Power Platform, update 17, built using the civil capabilities as well. As you know, in OpenBridge Modeler, we have included some OpenRoads tools. So they're also included the latest OpenRoads tools that are coming on the 2022 release 1. Pro Structures update 7. We're going to see the Generative Components, or GC, as we call it in short, and certified with these versions of ProjectWise and using this Gint and Descartes version. More information on the links below, and they're going to be published again when we fully release the software or make it available in your connect.bentley.com. So what we have done in OpenBridge Designer, right? You know, OpenBridge Designer is the one that encompasses OpenBridge Modeler and the analytical tools, LeapBridge Concrete, LeapBridge Steel, and RMBridge. So we have changed the user interface because now the user interface doesn't require an extra icon, for example, for Generative Components, because now Generative Components is inside OBM or OpenBridge Modeler. Pro Structures as well, because now if you have a license of Pro Structures, you can actually have the full version or the full capabilities of Pro Structures inside OpenBridge Modeler. So we have made these, I would say, cosmetic changes into the user interface. Right. Now, as well, on the OpenBridge Designer, we save the OBDX file, right? And you haven't noticed, we used to save kind of a backup copy of the DGN file in which the bridge was inside the OBDX, right? So now we stopped that practice. Some projects were getting way too large because we were saving again a copy of it. So we just don't do it anymore. Then we continually increase the interoperability between modeling and analytics. You know that we can just model a pre-stressed girder bridge and a steel-eye girder bridge in OpenBridge and transfer that to Leap Concrete or Leap Steel. But then what about if you need to model a steel top, right? A steel top for more advanced analysis now can also be transferred to RMBridge, in which you can just do the extra analysis needed for that particular type of structures. Now, what about OpenBridge Modeler? OpenBridge Modeler, as we continue from previous releases, and then the same as in OpenRoads practice, we allow side-by-side installations. So if you're working for different organizations or state agencies that require a specific version of the software that may be newer on what you have or older than this release, you can install it, and installs completely in a separate folder, and it uses their own workspace. So you shouldn't have any problems on that. Now, as different then as OpenRoads, every release of OpenBridge Modeler is considered a schema change. So it's always when you open an old file, let's call it like that, an old file, it always gives you the warning to upgrade to the latest version that you have. And there's an option, of course, and if you say yes, well then the files will be forward compatible only. Right? So this is happening since 2 previous releases. So again, and we continue the same practice on this new version. Now, what are the primary enhancements, or at least what we consider a primary enhancement in OpenBridge Modeler? One that was always, at the top of the request was the inclusion of a deck breakback, right? So again, sometimes they have different names, but a deck breakback is just basically a cutout of the deck when a skew angle is happening. So instead of having an acute edge at the end of the deck, at the beginning or the end, again, depending on the skew, the agencies were required to just basically chop it off, cut at a certain dimension the deck to prevent that. So remember, it was not only the deck that you need to cut, but then you need to realize how the approach slab is going to connect to it, where the barriers are going to stop or start after a breakback. So all these options have been considered. To specify that, actually, it's very simple on that, because what you need to do when this is, for example, one of the standards of a breakback, right? So you just need to specify that I want a 2 feet cutout. And of course, the software will do the geometry and put the deck for you. And I said it was very simple because it's just dialog box driven. So at the time you place the deck, or after you place it and you need to edit it, right? Because maybe the skew angle changes. So you just need to specify the distance. We customize it enough, and you can specify the distance for the beginning and end of the deck and the left and right of the slab itself. So just like that, specify the dimension and do it. If you need to edit it, right? So that's, for example, I apply 2 feet, measure it perpendicular. So that's what you can do. And of course, it will, before, the only workaround for that was to use MicroStation tools, and using that, you may lose the parametrics, so not anymore. Now, you can edit that and place it at the very beginning, or just edit it, and the breakback will just react immediately. Right? So very simple on that, and again, very useful, especially when the skew angles sometimes change and you need to prevent that, as I said before, acute angles into the deck itself. Right? Now, of course, not only that, but as well, it reacts, the dimension stays. If you change the angle, you don't need to do anything. It remembers that dimension, that vertical dimension, in this case, that you enter, and it will just recompute your deck accordingly. So the parametrics is still there, and then the new dimensions, that perpendicular dimension stays. So it's a very simple tool to use on that. Right? Now, more than that is, well, what you do with the other options, right? So it still obeys variable constraints, right? So you specify different dimensions, right, on the deck, still will recognize that and allow you to do variations. And again, one more time, that breakback will be maintained. So it doesn't need to be a regular deck. It could be a tapering deck, and still you will be able to do the breakback. So it's a property of the deck itself that can also be reported. Right? So more than that, what about the variable constraints or point controls that you may want to use? Well, you can also use point controls, like placing a new civil line, for example, right? Or an alignment, or even an alignment and a profile that you want to follow on your deck. Right? So you will be able to follow that, and again, the breakback will continue to follow that. So right here, for example, I'm adding 2 new lines, in which I'm going to use as a point control for my deck, and then tell the OBM or OpenBridge to follow that breakback, or to follow the edge of the deck following that civil lines that I selected. So check the properties and go point control, and specify that along on the left will be P5, right? Along P5, I want to follow that civil line. So activate that, and I want to follow it horizontally, right? I can do it if I define a profile along that line, I can define both. So the right edge of the deck or left will warp following alignment and profile. In this case, is only horizontal. So, and then when I select the deck, it will behave, and the breakback again will be maintained and computed. So it applies to all of that. Right now, on the breakback, if you have an abutment, well, if you're cutting this, remember you have an approach slab as well. So you need the approach slab to kind of fill up that gap or protuberance that is happening on the deck, right? So the approach slab will take care of that and fill up that. So it's not going to affect abutments that much on that sense if you use an approach slab. So continuing with that example, right? So I got a new deck here. I'm going to apply a breakback dimension for both ends, and the abutment is already placed, right? So we see. Right? So again, there is something extra here, and then there is something missing, put it that way, on the right side. So that's when I place my approach slab, we'll take care of that. So see, it's taking care of some of the clutter here. See what we're going to do. So, well, that's also a good example how to place an approach slab. That we introduced it on the previous release. Well, I'm showing you how to place an approach slab. So what we need is a reference line and say this is going to be a certain offset of 25 feet from the start of the abutment, right? So the abutment start, and it will place a support line. We don't call it support line because, well, it's not supporting anything. It's a reference line in which the abutment as a new item, right? It's not a deck anymore. We used to have a workaround and say, oh, let's create another deck. Now that we have an approach slab element, which is on feature symbology and feature definition. And then also then you can apply a breakback to the deck itself. Right? So, and that's it. So you got to consider that if you use 2 feet on one, well, the approach slab must have the same. Right? And there is a question happening, what about discrete elevations on that reports according to the breakbacks? Yes, it's available too. So we will consider that. If it happens to match that particular point, right? So as you change it or modify it, so then the deck as well will update and fill up the gap. So it's also part of that connection, right? And then the barriers will also know. And then also remember that on barriers on previous release, we got the option to extend or shorten the beginning and end of barriers, right? We used to follow that point, the edge of the deck. Now you can not only specify that particular point, but the distance in which they begin and end. Now, for the breakback, applying to the abutment itself, right? So, no, we were not, I mean, on the dialog box, we may be planning one, but then not at this time. Usually when it's some breakback needed on the back walls, and then there's more considerations like wing walls and all of that. So we are handling these to more complex scenarios with functional components, or later you will see if it's more complex than that, we can do with generative components, as you will see. Okay, so we can now apply that dimensions, and then on the, as I was mentioning, on the barrier, we can just apply that beginning or ending offsets for the barrier itself, right? So we can do all of that now. So that is the breakbacks. I extend a little bit even to approach slab, but then nothing is worth it, right? So the next one that we have is something that also was at the top of your request, in which our footings, right, up to this day were just, let's call it prismoidal, right? So it's either rectangular or square, and there was not that many options unless you create a functional component. So, and now if you are users of OBM, you know that we have custom columns, right? In which you just basically draw a 2D template of the type of column that you want and extrude it alone, and then you have a custom column. Well, using that same, let's call it technology, we did it for footings. So you just need to develop a 2D template of the shape of footing that you want, and then the software will take care of that. So it's not only for piers, it's also for abutments, and then it also considers the ability to put piles on it. So again, you just need to create a template for that. You can also, as I said, apply piles and tag its locations and use variables too. And when you place it, it's just a matter of selecting in the dialog box that you want a custom footing, that is the template that you want to use. In this case, is was shape oval footing, right? Then after that, the height and the pile locations and the pattern of the piles, it's all managed through a dialog box. So any particular shape that you may want, right? So then you could just, it's a matter of drawing the 2D template for that, right? Again, before the workaround was to just cut off the footings, losing the parametrics on the process. So now it's all parametric, right? Pile locations are also part of variables that you can do it as well, right? Not only works on piers, but also on footings as well, or on abutments as well, right? So it's just a matter, as I said, of getting that 2D shape. And if you look at the bottom, it also recognizes the 2D decorator, right? Kind of a projection in plan view, what that footing looks like. Right? Now, as any custom element, you got to be careful because, you know, leverage concrete or leverage steel don't handle this, right? So they just assume kind of a bounding box. When you have that type, at this time, there is no transfer to RM, right? Then what you need to do is, if you want the shape that you created to be used in another project, you need to export this template into an XML file. Before, this is a matter of selecting the DGN and incorporating to the library. That was one of the tricks that we use, right? But now we're trying to export these more consistently all through XML files. The same way we do for piers, beams, or decks, right? So let's see how this is done then. So what you need to do is, in the same XML file or the template files in which we have our decks, we will just create that template, right? So we give you a library for that, right? But then again, if you want to create your own, it's just a matter of copy one and customizing this, right? But then again, as you take a look at the list, we have variables, the same as variables that we use on deck. Now you have variables that you can define and point constraints that you want to use, right? So basically any 2D shape that you can draw, it could be not only custom, but it could be parametrically custom too. So, and again, you can copy one or create one from scratch. So it's just right click and add a new template, right? So again, same process that you were creating a deck. It gives you this temporary view with the working point in which you can start drawing using simple elements, simple commands. Again, nothing of complex chains or anything like that, right? So just draw your footing that you want, right? So again, I'm using simple lines, nothing, no complex elements or anything complex like that. So just define it, right? That will be for example, the shape of my footing, right? To start, then to locate piles, I can just reference this, right? So just as a point, right? It's not that you're drafting, the right side of the pile, because you can change it. This could be a representation. This is just a location representation, put it that way. It's not that, oh, this is going to have to be a circular pile, or I have to place an H shape, so it's going to be an H shape pile. No, this is just location, pure location. And then you can start placing, of course, how many you need, right? So that, yes, you have to place all the locations. It's not like, oh, I'm going to place 4 and then at the end decide that it's going to be like 12. Right now, you have to specify every location of the pile that you may want. Right? That it could be part of variables, and you will see is that distance, right? So the distance, for example, from the edge of the footing at the pile location, you can make it into a variable, right? So just placing that and tag the elements, what they are, right? So these 4 circles, for example, will be a pile location. So then the software will interpret that as we'll be placing them into the template, right? So, and it attached that name. So the same as the deck, remember that you used to have like P0, P1, P2, P3, P4, P5. Now you have pile L1 as a location, and so on and so forth. We bring the template into the dialog box back, and that's it. So now you can make it parametric. So, you know, like for example, the distance between P0 and P1, between P1 and P2, apply names, and the point constraints are the ones that are going to define that parameters for you. So you can add all these variables, right? So for example here, horizontal and vertical. So P3 will be control, and that will be the distance from the working point, in that case, the center of the footing in my case, or could be from another point. So nothing, I would say, new. It's just the same technology or the same way that you are defining to place a deck. And so you can apply chamfers to the footings and all these options. Again, this is basically the same dialogues as the deck templates. But of course, we use a little bit of different constraints, right? So, and that's what I'm applying on P3, for example. I apply the location of P3, so 7 feet down from the working point horizontally, or to left, and then vertically too. And P0 will be a distance from P3, right? Horizontal and vertically. Specify a variable value that it will be prompted to me when I select a pier, and apply a chamfer as well on P0. And then I will repeat the same process for P1 and P2. So now this footing definition of this template will be part of your workspace, and you have the right permissions, maybe to write into the workspace environment. If not, it will be part of your workset if you have that file available. So now you specify the location of P2, again, certain distance, in this case horizontally from P3 and vertically 2, and the chamfer on P2. So showing you different ways in which you can define that, right? And then now let's define the location of the piers itself, right? But now P1, oh yeah, missing the location of P1. And then again, as I tag it as location, so PL1, it will be offset distance from the P01 edge, right? And offset distance also from the P03 edge. So that will be the location of P1. Measure it from the vertical line made of P0 and P3, right? So that will provide a Y offset, right? And the X offset will be provided by the distance from the Y offset will be provided by the distance of P0 and P1. Right? So again, I can make all of these elements completely parametric. So I just define PL1, I will go with PL2. So it will be again at a certain distance from P1 and P2. Right? Provide a variable, and also at a certain distance from P0, P1. And be careful with how you define the vector, because that's the one that is going to give you the negative or positive sign for the distance itself, right? So this is going P3 and P0, for example. So, well, right is going to be positive, right, at that direction, right? And vertically is P0 to P1, for example, the last entry. So P0 to P1, so to the right of that line is going to be plus as well, right? So just be careful with that orientation. Then again, I just define my footing with the chamfer with 4 piles locations, right? So done. So then when I go place my bridge, right, place a pier, I should have now the option to customize that. I just created a template, remember that. So I have different piers here. This is the one that I use, right? So how to specify that I want a custom pier rather than the one that comes with the dialog box itself, right? So we enhance the libraries now, so you can make copies of it. But then let's edit that internal file to see how you add this custom template for you. So I'm going to copy one existing one that does not have this custom template. I'm going to make it custom for me. Right, so select it, go edit. Everything stays the same until I go to footings, because now it's not rectangular, right? It's not combined, it's custom. That is the new entry, right? And on that, I go to the template library that I created and just browse for it. And that's the one, right? So when I bring it in, right, these are all, when it loaded, these are all the dimensions that I have for me that I created. So these variables are populated from the definition of the footing itself. So you can see, I can change the dimensions of the footing, change the dimensions of the spacing between the piles, and that's it. The height is given by the dialog box itself, right? And I just see the distances that I can define in for the pile locations, right? And rotation too. So again, all of that is dialog box reading, as you can see, right? So control it like any other regular footing. The only difference is now it's a custom section. Right, and the piles, I just define the location of it, right? But now I would say that on that location, I want to use the pattern layout that came with the footing, right? Specify this case steel, and that will do it, right? I can also overwrite that and say, no, I don't want to use 4, I want to use 6. Right, so you can add there and override whatever is defined. And then, since I have 4 locations, I can also now play with the pile position itself, rotation, battery angle if I need it. So all of that could be used as well, right? So the template, it only defines the location itself. And then when you place it, again, like any regular footing, it will be place pier, place abutment, well, voila, you just place it, any custom element. So nothing special, you just use the regular command of place pier or place abutment. It knows that the library will have a custom footing there, and a custom piles, and it will just replace it. And of course, it is available for reporting, it's available for quantities, so all the elements are included there. So nothing special when you place that, it's just selecting and just place it. And so make it easier for you and then retain all the parametrics in between. Okay, and then again, obviously editing options and all of that are already included there. That's it. Okay, let's keep going. So now, this is also a major enhancement. I mean, tell you the truth, we are really excited about the possibilities that this inclusion in OpenBridge offers, and is the use of generative components. We just started using it to address the need of custom nodes like abutments or piers, that, especially abutments, that in some organizations are really complex, even includes decision-making capabilities that needs to be addressed when placing our abutment. So yes, we have functional components, and I mean, they're good. They address a specific need, but then sometimes that stuff that it can, I mean, we put it to the test, and then we realize that we need some extra stuff. And our answer for that in this release is on tech preview, is called Generative Component, or in short, GC. And basically, you can do whatever you want, right? It requires some, I wouldn't say programming, I would say more logical thinking, logical scripting tool. Don't get me wrong, you can put programs inside that tool, and little C+ routines if you want. But in general, it is just knowing the commands are connecting the logic in between. So some people call it visual programming, some people call it visual scripting. So it's just that you can define your own variables and address that need of applying this. Now, how this is done? Well, it's you need to, during installation, you need to ask for installing as well generative component. It's not by default, you need to ask for that. If you install it already, well, you will modify the installation and add GC. You need to activate it between in the software itself, right? So it will show up as an element for you. It's all done through config variables. Again, we are going to release extensive notes on that, on how to activate it. Right. Then also here is that GC, it works with what we call nodes. So these nodes will be our abutments. Again, maybe not, it's not like everybody's going to start doing GC, right? But what we provide, or the organization will provide, a library of the type of, for example, abutments. You would have 6 different types of abutments. You may provide only 2 GC nodes or GC abutments, right, that will address all that 6 particular needs that you have. So as a user, the only thing I need to do is just basically say, I want these abutments to show up for me. Again, I don't need any of these GC dialogues that are coming. So again, I will just place a regular bridge. I'm just going to just place a bridge maybe with the wizard, and then I will just go and say, okay, I need to do my GC, right? So I will just load this as a library item. So you see abutment 1. And then when I place it, I want to say, okay, since I bring the GC, this abutment that I place needs to be part of the bridge. So I need to, let's call it, map the variables in between the abutment and the actual bridge itself, in which we say, okay, this GC node, I want it for placement. And I wanted to read some of the variables that are defined in the GC, make it part of the bridge, like the skew angle that I define in the GC node or generative component node. It matches the placement skew angle of the bridge and read offset from the profile. So then after that, it's just, okay, this place a custom pier. So nothing special, just place it as any regular pier. It will become part of your library. just place it. So the same, select the support line, right, accept it, right click to end, it will just generate the pier for you. So now basically what I can say is that the GC engine that running these, it's all included in OBM. There's no extra software that you need to do. It's for the end user. It will be just placing a pier with a special item, right? We put it under custom pier to make it general, so we make no differentiation between if it's abutment or a pier. So we just put it on the dialog, and you're gonna place another one, same, select it, among all the other elements, and we place it. We can obey, of course, the active angle, the skew angles, and all of that, but we just place it as it is, and then let's start modifying it. Right, so for example, I will place this GC element. Maybe it's not the dimensions that I want, it's all using the defaults, right? So that's what it has done. I'm going to zoom closer. You can see the complexity could be, for example, that this wing wall has a corner block or a hinge between the back wall and the wing wall itself, so it needs some decision making. If it's a certain angle, I need a certain distance, right? So so the entire abutment in this case is placed, right? So, and that's by default, right? But then what about if it comes, if I got super elevation, if I want more piles, if, oh, by the way, maybe the skew angle changes of the bridge, or maybe I need to skew not the angle of the actual support, but just the angle of the wing walls, the left, the right. So all of that needs to be considered. So what we need to do is switch to the workflow to computational design, that is GC. So we will access that, right? And this is the logic built in already by the administrator. So I got two piers placed, and I need to change the properties of the second pier, let's call it, but actually it's an abutment, and double click, and I have a list of all the variables that were defined for me. And then I just need to adjust that variables on what I need, right? So whatever the administrator did or the creator of that GC node consider appropriate. So, and then for me, it's just a matter of what is that? Oh, the right footing of the wing wall. So change the dimension that is given to me, enter, and the element will just regenerate right in front of your eyes. There is no executable needed, it just does it, right? So maybe the number of piles are not set, but the battery angles are all zero. So again, if it's on the variable, I can define any dimensions and it switches immediately, right? And then of course, we're making more efforts. This is a technology preview in order to match variables on the bridge, variables on GC. For example, the width of the deck, right? We wanted to read it, the cross slope on the super elevation. So we don't need to enter the super of the abutment itself. So we can just read it directly on that. So on both sides too, or here, for example, that, oh, I put the pier backwards. So I will just change it, right? Or place it again and recognize all that differences. So I can just modify it on the fly if I need to, right? So, and then on top of that, I can try to enlarge this now. Okay, so for example, what happened if I place it, right? I fix all of these, I got the abutment that I want, but then they said, oh, we need to make the bridge longer or shorter. So then just do it, because the GC element that we're placing is not just a GC element, it's actually, as Francois mentioned it, a civil element, a bridge element per se. So for example, here, I'm just changing, and this abutment will just move. This GC abutment, well, that is actually a bridge element itself. So it will update the bridge accordingly. If I need to map new variables or just modify variables, I just go in and change it. So That is, again, the advantage of running the GC engine inside OVM. Now, what is the next step? The next steps are be able to compute quantities from it, add features or item types into that. So this is coming as well, but not in this release. It will come from our next release after that. So, but again, this is a work in progress. But at this time, this is what we can offer you as a technology preview on placing GCS nodes. We have a library of nodes coming in the release as well, so you can start experimenting with that or creating your own GC nodes. Right? So it's a general tool available in Bentley. It's called Generative Components. There is also materials on the LEARNserver in which you can use. I mean, this is the first time we're using these on our civil product. Generative Components was being used for a long time in buildings, in open buildings, but now it make its way into our civil elements, especially OpenBridge, just to address these complex scenarios that, hey, every bridge project is unique, so that's our solution to it. We're running out of time. Again, these are the three major ones, enhancements on this, right? That I told you these are some of the limitations that we have in GC right now. Right? And again, of course, we're going to keep improving this. Right? But then we have a lot of additional enhancements, right? And I'm not going to go through the whole list. I mean, as I said, we're running out of time. But I can tell you there are 40 new enhancements that we call it additional, but again, it could be major to you as well, because this just maybe right the feature that you need for your project. So again, we are doing coffee corners in the next weeks to address that. We're doing extra presentations to address every specific one of them. So just keep in touch. I can just give you the list as part of this recording and an explanation of every element that's coming to you in this form of enhancements, right? Actually, mistake, it's 41 enhancements, right? So options of the wing wall that it was straight, for example, and then now we can apply a slope to the top of the wing walls, right? So you can do these kind of constructions now. Before, again, there was no way to do it. It was functional components was the only answer, but now you can do it right from the dialog box and modify too, right, after you place it, right? Vertical offset as well on the wing wall. It used to be flush to the back wall. Now you can apply certain offsets, positive or negative, right, for that. Somebody asked about what about the screen elevations or elevation reports on the approach slabs that you have. We have that now in this release. So you can have a specific approach slab elevation reports following the edges of the slab. If you also extended the barrier to it, so yes, you can do all of that, right? Options on inverted T's to do a crowned slope as well, or crowned deck, right? Our cheek walls now follow the edge of the cap, right? Usually it was rectangular, but now we can just apply different fillet sections to it or chamfers. So the cheek wall that you place, it will be the same. Bearing seats, skew for the support, right? Then for the step caps as well, right? Connection plates, again, when we're doing cross frames, our gusset plates were straight, right? Now they wanted to follow the diagonals, for example, so we can apply that options to us, right? A new option as well to reference the placement of the struts on a cross frame. It used to be just, I would say, geometry, right? Top, bottom, middle. Now we include the center of gravity of each of the struts that you want to place. Could be used as a matter of placement, right? Double angles as connectors too, on steel. So we can use that too. We can vertically center the cross frames, especially when you are in super, right? So we can just all align it. Now, for the OpenRoads users that are very familiar with linear templates, well, we have the same command with the template library into OpenBridge. Again, this is a presentation coming soon as well, how to use this, especially for grading abundance. So you have seen previous presentations of OpenRoads, how to use this command. Well, just research. This is how to use it. It's exactly the same, but then it's part of OpenBridge. And hopefully that will end the debate of who does grading or who does the retaining walls. Is it roadway or is it bridge, right? So now we can say, yeah, bridge, we do it all. So just take a look at these linear templates. There is extensive material in the OpenRoads library on the LEARNserver. Again, we're going to be customizing this as well for our future presentations in OpenBridge. Enhancements on the wizard too. Right? So sometimes we want to use our functional components or elements, so we don't want to place the library abutments or piers or barriers. So we have the option just to generate the decks and the beams. That we have a faster input, a faster execution tool, right? So like, we have a project, the user have like kind of a more than 80 or 100 spans on a coastal bridge. So to do it again manually will take a long time. So we enhance the wizard to address these massive scenarios as well. Right? And some error checking and the information too, right? Because as you switch from dialog to dialog, we have the option to save or cut and paste the properties too. So it's a little enhancements that in the wizard, but then again, at the end of the day, it saves a lot of time, right? On piles, rotation angles, we can do, and look, we're running out of time, and then we're still on the 16 item, and we're missing all the way to 41. So as I said, we can break it up these in future coffee corners in which we can approach these element by element, right? So in YouTube as well, we have recordings on this. When the release happens, it's going to be released a lot of material on the LEARNserver, YouTube, and then again, coffee corners and extra presentations that we're going to do in a future in-presence conference now. So enhancements on the echo reports,